So thank you for coming to the R workshop session 3. And again, my name is Jingjing Wu, and my colleague Cynthia Henry and I will run this session together. We hope you stay warm and safe. We will record this session, but both Cynthia and I experienced some technical issues. So hopefully we can get the recordings done correctly. And anything else? Yeah. Before I start, I point you to the coursework for this session. If any kind of technical issue come back, we could not continue, but you still can get all the content from here. Okay, I can. Where is the chat box? Oh.
Yeah, maybe behind.
Okay, yeah. Yes, I just put the coursework page here, so yeah, you can always come back. Anything else? Okay, so let's start. So in the first 2 sessions, we talk about data types. The most used data types are character, numeric, or double, and logical and integer. We also discussed data structures, vector or atomic vector, which is a serial of values of the same data type. And in session 2, we talk about another data structure, which is data frame. And it is used for tabular data, like Excel spreadsheet, or CSV files, or Google Sheets. A data frame is basically a rectangular, 2 dimensions. Each row is an observation, and rows or observations are lists. We mentioned lists in our first session. List is also a vector, but it is the vector contains values of different data type. Okay, maybe I can quickly. Oh, we can see that when we review the data. Okay, and each column is a variable, and the columns or variables are atomic vectors. So those data types or the data structures are the very foundation of almost all programming languages. But in session 3 and 4, we will cover data wrangling and visualizations, which is kind of more practical. And the packages we're going to use are dplyr, tidyr, and ggplot2. So they are all under the same umbrella, tidyverse, which we already installed. So now we will start our coding for this session. So first, I'm going to open the RStudio project. For me, it is on my desktop. Okay. So first thing, we're going to create an R script. And we will add some information for this file. Let's say title data wrangling, and you can put your name here and also the date. Today is February the 3rd. We can save this file to the scripts folder. we name it day 3 and just call that data wrangling. And before we can do any coding, we need the data to read data in, and also we need tidyverse to help us to kind of allow us to use all those functions. So to read tidyverse in, we use the function library. Tidyverse. Okay. Okay. And then we're going to read the CSV file. Oh, the file name is interviews. And read underscore CSV, and we know the file is under data, and the file name is sarfi underscore clean. That's the CSV file, and we already see they use now for missing data. We want to replace it with NA. And we can take a look at this interviews. Okay, that looks much better. Okay, so this is the data we used last time, and we know it has 131 rows and 14 columns. So you can see the data here. And also, we just mentioned each row is an observation. It is a list. It is serial of values of different data type. Let's say for the first one, it can be a number, numeric or double. And for the second one, that is a character. So this is a list. And for each column, each variable, it contains data or values of the same data type, all the years of, I don't know, it's life or leave. And this column, all of that data are numeric.
Jing, I think we're having a few questions about what does library tidyverse do? And I was just saying that that pulls that package in, but I wonder if we're having people stuck at that one step. You can see our screen that it in the console area that it pulled in that package.
Yes, it's kind of, we already installed tidyverse, the package, but every time before we start a new RStudio session, we need to load the package we already installed so we can use it. Tidyverse is a package of kind of a collection of packages. The package we're going to use today, dplyr and tidyr, are all packaged in this package, tidyverse.
So also, I think we have some people that are just joining here on the third time because people are for the CSV file.
Mm-hmm.
We loaded that on the second session, right, Jing? Or maybe
yes, the second. Yes, we
yes.
did.
And so we put that in our folder, in the data folder that you can see on her screen, and it has the data, and the file is called Safi, SAFI underscore clean .csv.
Okay, so we can come back. Let's say we already have the day 1 script and day 2 script here. And I think we kind of download the file in session 1.
Yeah, I thought so. I thought we moved it to session 1 this semester. So if you don't have that file already,
I mean, if they don't, maybe we can copy the. Oh, why didn't I have the?
okay, we're
data?
having somebody else is having to do some setting of the directory. I think we're just all kind of, setting up probably maybe in a different space. I know Jing Jing and I are working from home now, so we're on different computers. And so if you need to take a minute and find what you need, and then maybe we'll start again.
Okay, let me quickly.
So I think we need to kind of, look at, see if the people that are asking questions, did they find the CSV file now that we explained where it was? And then are we all together kind of?
Okay, so if you're working, you don't, usually we don't need to reset the working directory. Brad, I think you already have this folder.
He was working on a different project earlier, so he's just kind of getting himself together, I think.
Whatever project you're working on or you worked before, and as long as you have this folder, and you can always open this folder and click this R project file, and it will bring you to the
He's all set now.
okay, to the correct working directory. The
Yep.
working directory is still, it's on the desktop and this folder.
Lee, how are you doing?
Hi. So I did not attend session 1 and 2, so I did not have a chance to download the file.
Mhm.
I wonder if somehow you can share the link with me so that I can download it now. Or
Do you
if
have
it
R and
has
RStudio
possible.
installed?
Yes, I do.
And
Okay,
I think the
do you
file
have
is on the
tidyverse installed?
Yes.
Okay, so if that's the case, let me see. You can create a folder, whatever name you want to,
Okay.
and then create 2 subfolders in that.
Okay.
Oh, no, let me see. Say it again, sorry. You can create our project from here, from this folder.
And
Okay.
I think she can get the file off of the guide, and I dropped the guide link on there. So you can download it from there.
Mhm.
Don't you think?
Yeah.
Yes. Okay, so Andrea, the same thing. From the guide, you can find the,
Okay.
you still have to do what Jing Jing's saying. You have to gonna put it into RStudio somewhere, but you can get the file to download from the guide.
Okay, I will do that. Thank you so much.
Okay.
Sure, and you're not the only one. I think we have another one. Andrea is in the same position as well.
Okay, here is how you download the file. I just put this into the chat. Hopefully I can find chat. Okay.
Yes.
So you must have the data subfolder first,
Yes.
and then it will go directly under this folder. If it's not, if you don't have this data folder, you could not use exactly the same path as we do here, but you can change your path.
I'm sorry. And can you show me one more time, how do you create a folder? Like, do I just create a folder on my desktop or?
Okay, you can, let me think. Okay, you can just create this.
Okay.
And oh, let me see, cancel. Oh, no, I clicked the wrong thing. The second button, it will allow you to create save current workspace. Oh, that will create a new. Okay, you will see a different screen as I like this one. That will allow you to create an RStudio project.
I'm looking at a window saying create project, and then there are three options: new directory, existing
New
directory.
directory.
Okay. All right, thank you so much.
And then you will select, let's say you select desktop as I think the first field, the first blank will allow you to input the folder name, the directory name. And then that will allow you you have a drop down a selection there, and which allows you to how do I say that, decide where you want to put this directory. Does that make sense?
Yes, thank you.
And then from there, that folder will be your our workshop folder. That will be the directory name you put in the blank space.
I think I got it. Yes.
Okay, and then you can create these two folders. You will have the same structure as we do.
Okay, thank you so much.
Okay.
And Andrea, how are you doing? You okay?
I'm trying to create the folder. I download the file, but I'm still creating the project. I'm kind of stuck there.
Okay.
Is
Okay, so I think that's all we need. So we are kind of on the same page now, right?
I'm sorry, the directory name, should I put only desktop? I missed that part, I'm sorry.
The directory name you can put, for us, we use the R workshop name, and you can name it whatever you want. That will be your working directory.
Okay.
And the drop down you can put, I put it on the desktop to make it easier to find. So you can put it under documents or wherever you want.
Okay. But create project as a subdirectory of desktop. That's what I should be doing, right?
Yes. From here, you create a project and select new directory. Mm-hmm.
Okay. Thank you.
So, okay, I think I have that file here. So anyone who doesn't have the data, I can just paste this command. Then you can download the file to the specific folder. And then you have to install tidyverse, and then we can load tidyverse using this function library. And then we read this CSV file into a data frame, into an object. It's called interviews. You can view the data set this way. To run the command in this script editor area, we use Control-Enter. So now we are going to talk about data wrangling with dplyr. dplyr is a package we use to wrangle the tabular data. We can use dplyr functions to subset data or add data or do some summary statistics. So today we're going to cover a kind of 6 or 7 functions. First, we will talk about 2 functions for subsetting data frames. Last week, we used 3 symbols to subset data frames or tables. So first we can add a session here. This is Control-Shift-R, and we say, okay. And so before we used square brackets, double square brackets, and $sign to subset data frames last week. But today we are going to use 2 different functions. One is called select, and another one is filter. We will see the difference. Okay, so for the function select, the first argument of the function is a data frame. And then it followed with column names. So the function select is kind of allow us to select columns we want. We can select one column or multiple columns, separate them by comma, or we can use the colon kind of to select a range of column names. So first we can see an example. Select the first argument is the data frame for us, that's interviews, and it followed with the column names. So let's say village is a column name, and number of household members, and months lack of food. Control Enter, and then we can run this command. We will get a table. It is 131 rows and 3 columns. We select only 3 columns from this data frame interviews, but we got all the recordings. We got all the observations, got all the rows. We can also use colon for the range, let's say. And from village through respondent war type. So this time the first column is village, and the last one is respondent war type. Last time when we subset data frame, we mentioned we can use minus to exclude columns or rows, but using select, we can use minus to exclude columns. Interviews, let's say. So now the new data frame we got, it has the 131 rows, but only 12 columns because we exclude 2 columns, village and month/food. And next, we're going to talk about filter. We use filter to choose rows. The first argument of filter is also the data frame. And then it followed with conditions. So conditions are kind of the logical test results. When we use the square brackets, we specify the row numbers. But when we use the function filter, we subset the data sets on conditions. So see the first example. First argument is the data frame we want to subset. And the condition, let's say, village equals to the C village. Okay, here we use the double equals. It's kind of a comparison. The single equals is the same like the assignment operator. So this time we got a table which is 39 rows and 14 columns. This 39 rows, all the village equals to this C village. We can also kind of use the logical operators and or all to combine the conditions.
So we're getting some confusion there. Not everybody got the same table as you did.
Okay.
Um,
Get in 0. Okay. So did you spell this correctly?
so he dropped filter interviews village equals. Non-caps. It's non-caps. He's got
Ah, okay. Okay. So we talk about kind of multiple conditions together, and we will use the and or all to combine them. So first we start with and. So still we want the village equals to then we use and rooms greater than 1 and number of meals greater than 2. Okay, when we run that, we got a 10 by 14 table. Because it's kind of narrowed down, it has to meet all the 3 requirements. So it has less records or less rows than this one. And for the AND operator, we can use comma to replace it. It means the same. So if I change and to comma, I got the same results. Still 10 rows. And we will see all logic. Or we will use the symbol is kind of shift backslash, or the one right under backspace. We want the records, we want the observations, which the village is either C village or R village. When we run this command, oh, you see, oh, sorry, I should use double equals. Yes. And this time we have 88 rows. If you are still with me, could you click the red green check mark on interactions? Oh,
We're getting about half are there.
okay. Okay, do you need more time? If yes, just let me know. So I did not see anything, so I'm going to move forward. Okay. Sometimes, often we want to kind of, how do I say that? We want to filter something and then select the same, we want to do the select and filter at the same time. And there are basically 3 ways to do that. So first thing is we can use the intermediate steps. And second, we can use the nested functions. And third, we can use pipes. We will talk about them one by one. The first intermediate, let's say we want to filter the interview data frame. We want the village equals to that C village. And then we want to select only the columns from village to respondent war type. So first, we are going to create a new data frame, new object, interviews 2. And then that will be, first will be filter. We filter interviews using the condition village equals to that C village. Then we will create another object. We will select. Instead of select interviews, this time we are going to select interviews 2, and we will select columns village through respondent war type. Okay. And we want to take a look at the results. So in this new results, we have 39 rows and 5 columns, which is the 5 columns we just select. The second method is using the nested functions. So using the nested function, let's say I'm going to show you create another object. Let's say we use the filter first and then select. So this time we put select first and then filter. We will filter the data frame interviews, and then with the condition village. And finish this whole parenthesis, and then we add the columns we want to select, which is village through respondent war type. And we can take a look at this interviews for. The same, we got 39 rows and 5 columns. These two ways, or these two methods, the first one, we have to do an extra step. The second one is kind of clean, but if we have several functions nested together, it will be difficult to read. So we will introduce the third way. So we can first take a look from here. Okay. The third way is pipe, but I can show you here. This is the second way. The first way we use the intermediate step. So we create this intermediate object and then use the results as the input for the second step. And the nested function, we can just replace this yellow highlighted part with this function. So filter, we just replace this square with the whole thing. That will be nested. And the third one, pipe, which is kind of like we how do I say that? Pipe will send the left part, the left of the pipe, to the function right to the pipe. The pipe symbol looks like this: percentage greater than and percentage. And it will send the result of the first function to the next function, to the function right to the pipe. And it also can send a data frame to the function right to the pipe. Okay. Back to the code. We already know the function. The pipe looks like a percentage greater than percentage, and the shortcut for this is Control-Shift-M, M for math. So if you are using Mac, that will be Command-Shift and M. So we can see the example using pipe. So we put the data frame at the beginning and then followed with the pipe. And then we use the function filter. Then pipe, select. We will select so we got the same result. The data frame will go through pipe to the first parameter of the function filter, and the result of everything left to this pipe will be sent as the first argument of the function select. Some people just read the pipe like the word then. So for example, in this here, we can kind of read, we take the data frame interviews, then we filter for rows with village equals to the C village. Then we select the columns from village through respondent wall type. So next, we're going to talk about another function. It's called mutate. Mutate, we can use mutate to add a new column based on the existing column. Okay, so in our example, let's say we have a number of household members, and also we have how many rooms in this household. And we can calculate people per room. So we can start with interview. I think I missed an S, interviews. And then we use the function mutate. We create a new column, it's called people per room, which equals to number of household members divided by rooms. And then we see the result. We got 131 rows, but 15 rows. And because we don't have the screen size limitation, it won't display all the columns, but we still can see the last column added, that's people per room. If we want to see that, we can add a pipe and send it to the function view. And then it opens a tab where we can view the new data frame. So it's people per room. And instead of kind of showing the name of the data frame, it has only a dot, which means the current data frame. So when we analyzing data, very often we split all the observations into groups. And then we apply some analysis for each group. And then we combine the results. We call this kind of like split, apply, and combine model.
Jean, can
In
you
deep,
tell us
Uh-huh.
again about the dot? Why is
Mhm.
it different than the interviews frame?
This one, we add a new column using the function mutate. So you can see it at the end, we have people per room.
Yes. And it labeled it just as a dot because,
Because we don't name it, we didn't really name it. Here, oh, no, not this one. Okay, yeah, here we start from the interviews and then we add a new column, but we didn't really name this data frame. So it is the current data frame. It used dot to kind of present it, represent.
and that's not saved anywhere, right? We would have to save that new.
No, it didn't save anywhere.
So if we wanted to save that, we would have to do something about that before we close.
Mhm.
Yes, okay.
Yeah.
So it is ephemeral?
What does that mean?
I don't know, Brad. You're gonna have to say something. I'm sorry. Is in the ether? Is that what you mean? It disappears?
Yes,
Yes.
you're right. Mhm.
Yes. Okay. Thanks, Brad. Sorry.
Okay. So we just talk about the split, apply, and combine model. So in dplyr, we use the function group by and summarize together to implement this model. Group by is kind of, we take column name, which we want to split the observations by. Let's say we want to see every village. So we can split the observations or split the rows by village. And then after we split the observations by village, and then we can use the summarize to collapse each group into a single row. Okay, we see an example here. So can add the function we use a group by and. You can, for summarize, you can use Z or you can use S. So R supports both UK and US spelling. Okay. So we still start from interviews. And then we group them by village. And then we summarize. I'm going to use SE, and you can use whatever you want. And let's say we want to calculate the mean of household members. And which equals to the function mean and number of household members. I think I spell it correctly. Let me check. Oh, yeah, no. So to summarize. I summarize. There must be a misspelling. BR.
Oh, there you go. You got it.
Okay. So here it says object number of not found. So I think, oh, there must be a misspelling. Okay. So here we can see the result. Okay, the village, it's kind of organized by village, and those are the number of household members by each village. If we remove this row, group by, we will still get a result, but it will be only one result. That's the average of household members across all the 131 rows. So we can also group several variables and summarize multiple values. Okay, so we can see and so we still start with group by, and except for village, we will add member of associations, which will be yes or no if they are a member of an aggregation irrigation association. And then this time we want to calculate still the mean. I can just copy this. And then we can calculate something else. So this time you can see the results categorized by, is grouped by two variables, village and member of association. And so the mean and the minimum are calculated separately. So about group by, there's another function called ungroup. It is a good practice, or it is a good habit to ungroup after the calculation. And also group by can be used with other functions, except for the other than the summarize. So we can see an example, let's say how ungroup works. We still group by village. And then I think I already have this copied. Yes, we will have mean we will add a new column. And then we will add another new column. And then we will ungroup. Village is not, oh, okay, lowercase v. Okay, so before we have only 14 columns. This time we got 16 because we add 2 columns, mean of the number of household and the minimum number of household. But if we change the ungroup from the end to the middle, oh, okay, sorry. I think, okay, I think we didn't really see those numbers. Huh? See, how could I show the numbers? We can select only those 2 columns. Okay, so so this result is grouped by village, and then we do the calculation. So we can see the same village should have the same results. Let's say, hopefully we can. Oh, we still don't see the R village. Oh, totally, we don't have that. Oh, let's see. Sorry about that. Okay, so this way we display the last 20 rows, so we can see the R village, the G village, and also the C village, the results. And then we can see R village, it's 7 point something, G is 6 point something, and C is 7, just a little bit above 7. So we can see the 3 different results, the average. And for the minimum, they should be the same. We can see 2, 3, and 2. Okay, if we ungroup before the last calculation, we will see, I think we should see a different results. Okay, and we can select. And this time we still want the the last 20 items, the last 20 rows. Oh, I think I need to. Okay, so this time, first I have to include village because I already ungroup it. And then you can see the for the mean of the number of households, we got the same results, 7.57 and 6 something and 7, a little bit over 7. But for the minimum numbers as we ungrouped here, so we got only one result. That will be the minimum across all the 131 records. Does that make sense? So ungroup, that will kind of do the opposite to as the group by. So it kind of will release the group. Okay, if you have any questions, you can just post in the chat.
Yeah, so we have a question. The ungroup function is just to undo the group by function.
Yes, kind of like that.
And I'm checking the code BC of error because of error.
Okay.
So Brad is having an error maybe,
Uh-huh.
but he's looking.
Okay. So I post my code here. If you can copy, and that will be easier. Otherwise,
He posted his own too. Let's see if we can read it real quick.
okay.
Help. Okay. Oh,
Minimum and select. Yes. I think there is a misspell. Oh, ER. Okay.
yes, it's at the end. Do you see that? It's right above the ungroup, the last one. It's members. You actually have the E and the VE.
No, I think that there's nothing wrong here. I think you both have yeah, E at both places. That should be.
No, there is one. So the last underscore members is spelled MEMBERS and yours is not.
No, this should be the same as this.
This should be the same as what? I didn't see what you marked up.
This is the name of the new column, and this is the column we want to keep. So as long as these two are same, it should be right.
Okay. Yes.
Okay. Oh, sorry,
Yeah.
I did
Brad, did
not
that
put
fix
it
it for you?
here. Okay, I can move it here. Let's say as long as this one is the same as this one, we should be okay. But let me run this and see what I get. Yes, I don't see anything wrong.
First mutate. Yes, for the first mutate. Brad. Let me see. Oh, because you also have in members there too. So members in this doesn't have the E, the second E, the BER, it should always be BRS, Brad. And you're typing it like a normal English word instead of,
Yeah, I've taken the ease out. I'm not sure if I
Okay.
did something earlier that's making it.
Okay. Did you rerun it then?
Yes, I have. I'm
And
not
it
sure if I've
still gets
rerun it
stuck?
from, yeah, I'm not sure. Maybe I need to rerun it from higher. I can't remember how far back this was generated.
Right.
Okay. Ah, I know what's going. You missed a parenthesis at this line. It should be two parentheses, two right parentheses, and you had only one. Let's run it. Okay,
Yes.
could you find the function?
Interview.
Where's the function interviews?
Do you have to run that line first and then run that?
We had never seen interviews. as a
Thanks.
function.
Does that make it work?
Work? It still won't work on my. Oh yes, it worked.
There it goes. Oh, look.
Okay. Okay, so I think, yeah, that's the missing parenthesis is the one kind of fix the code. Anyway, okay, so we're going to talk about another two functions. One is arrange, that will sort the result ascendingly. Okay, let me put the function name here. That's arrange. Ascendingly. Okay, so let me see. We can steal something from the previous results. Okay, let's do this. I just copy one and then I add pipe and then arrange.
Why don't you drop that in the chat as well, that copy part?
Okay, oh, I can.
There you go.
Oh, I forgot to put the. Yes, okay. I forgot to put the variables we want to arrange. So we want to arrange it by the minimum members, and then you can see it is ascendingly arranged. If we want to reverse the order, we just add DESC. And we run it again, so we will see it's reordered. So the last function we're going to talk about is count. So that's kind of count discrete values. We can see some simple examples. Let's say we want to count the respondent wall type. We know that I think we have four wall types. So they will count how many of those wall types, how many of those households are built in those burnt bricks, and how many in cement, and how many in other two types. If you want to sort it, you can just add argument sort. So it will sort we don't have time to kind of do the exercise in the workshop, but I highly recommend you kind of go through this these exercises. I think there is one right after pipe. Yes. And also another two exercise I think it's really helpful is this one. It's kind of after, kind of right before we start the reshaping, right before we start to use the tidyr, and the second and the third questions. You can do it kind of after the workshop. So we can take a 5 minutes break. We will be back 3:17.
Thanks. It's snowing again at my house.
Okay, yeah, it's, thank you, Cynthia. Oh, so it's already 3:17, so we're coming back for, yeah, coming back. So first I'm going to kind of try to explain the group by and ungroup. So I kind of make a little bit of change to see if you can see that better. Okay, so first we group the data frame by village, and then we calculate the minimum. That should be 3 different results, as we know we have 3 villages. And then we ungroup it. Then we kind of canceled the group operation, released the groups. And then when we do the calculation, that's something like, we don't even have those groups, which means we are going to get the mean that's across all the 131 records, 131 rows. So when I run this, and you can see the minimum, which is still grouped. We are supposed to get 3 values, 1 for R, 1 for G, and 1 for C. Unfortunately, R and C had the same value too, but the mean of the number of households is all the same. So this is this calculation is after we release the group. This is a mean. After we release the group, we get only 1 result, which is the average of all the 131 rows instead of the average by each group. Does that make sense?
Yeah, we're getting a few thumbs ups.
Okay, cool. So next we're going to talk about tidyr. And we use tidyr to reshape the data to different formats, from long formats to wide format or vice versa. So first we're going to talk about tidy. What does tidy data mean? So, oh sorry, this is not. Okay, here is the slides. Okay, tidy data, it must follow 3 principles. The first is each variable must have its own column, and each observation must have its own row, and each value must have its own cell. The concept kind of comes from Hadley Wickham. We mentioned his name. He's the author of the R for Data Sciences. We mentioned the book the first time. And this concept kind of comes from his article, Tidy Data. And we also have this article here in the guide. So if you're interested in that, you can find it here. And we can see an example. We use the schedule of classes as an example. So on the left, this is kind of a schedule of classes. So we can easily tell, let's say Wednesday, we have a physics class, and also we have a biology class. But is this data tidy? We can check with these 3 principles. So first, each variable has its own column, but our variable names, our column names or variable names, they are not really variables. They are just Monday through Friday, which can be the values of a variable day. So we follow these three principles and reorganize the data. It looks like this. So we kind of create four columns: ID, class, day, and time. So now we can see each column has its own, each variable has its own column, and each row, each observation has its own row. One row is one class, and each value has its own cell. So this is kind of the tidy data. But if we want to answer a question like what classes I have on a certain day, this one will be difficult to answer. So this is the tidy data. This is not tidy data, but we call this one wide format. We call this one long format. Basically, it's come from their look. And the format decides the readability of the data. So we can see another example here. We reorganize the same data and kind of reorganize the schedule by day and by subject. So with this data or this table, we can easily answer the question like we have two English classes every week. So this is also kind of the wide format. So each data set may have multiple wide formats to serve different purposes or answer different questions. But the long format or the tidy format is always the same. And in the coursework, it also talk about the longest format, which always have three columns: ID, key, and value. This ID is the same as this one. It's kind of like each observation has one ID, and key, which are the variable names, and values, they are just the value for the corresponding for the specific variable in a specific let's say let's say this example, this study, this is just the first observation, and this is the name of the class. So the long and wide are kind of relative. The longest format is more for machine, and it is not tidy. In R, to convert data from between long and wide, we're going to use two functions. One is the pivot wider, and another is pivot longer. So here we have a new session. So first, we are going to talk about the two functions. One is pivot wider and another one is pivot longer. So for pivot wider, it has three main arguments. The first one is the data frame or the table. The second one will be name from. Okay, so we still can see the slide. Here. Okay, so the pivot wider, it has the first argument is the data frame, and the second one is the names from. So which is the variable whose values will become new column names. In our schedule of class example, it will be the variable day. So we call this variable kind of like names from. And the third variable will be the values from, which is the column variables whose values will fill in the new column variables. So we can see it here. This is the values from. This column, that's the names from. So when we kind of change from the long format to the wider format, we will use the values from this column as the column headers, column names. And then we will fill the table or the columns with value from this column. Let's say for this row, the wall type is some breaks. So here it is true. All the other three is now it's NA is missing data, but actually they should be false. The true comes from here. Some breaks, and this is how the long format is changed to wider format. Okay, so we can kind of see how it works. We will create a new object called interviews wide. It starts from interviews, which is kind of the first argument. And then okay, as we know, we don't really have this column. We have 14 columns, but we don't have one called wall type logical. So we need to add this column. We can take a look. Oh. So it opens here. We see we add a new column like this. It looks more like this. We have this column, and we already know we have the respondent wall type. And then next, we're going to use the pivot wider. So we will use names from. And also we are going to use values from. Names from will be the respondent word type. And the values from will be the new column we just created, word type logical. Okay, we can send them to view. Okay. So we can see the we already have 4 new columns. Added at the end, but we don't have the column, let's say, respondent word type. I think it must be kind of before rooms. Let's say here, respondent word type is between years, life, and rooms. But when we use the pivot wider, and we won't see that because this column is kind of converted to these 4 columns, the same as the column we created, the logical, the word type logical column. The value is already here, true. You can see those truths come from the respondent, the word type logical column. Those NAs means missing data, but actually they are not really missing data. They are supposed to be false. The first row, the first household, I think it's the word type is Maddaub. It's not all the other 3. So we want to replace these NAs with false. So we can add another argument, which is values fill. And we will fill that with a list. Okay. Then when we view it, we can see, type. Sorry. Okay. So the NA is replaced by false. And then we can take a look at the pivot longer. Pivot longer, it basically has 4 arguments. The first one is still the data frame. The second one will be columns. Currently, we have those 4 columns. We want to convert them into 1 column, which will be the respondent word type. So the first column, the first argument, the second argument, I mean, is columns, which are those 4 columns we just saw. And then we will put those 4 columns into the column respondent war type. So this will be the third argument. It's called names2. And where are the values comes from? That comes from the war type logical. So that's the third, the fourth argument. Okay, so we can take a look. So this time, instead of starting from, okay, we will create the interviews long. And instead of starting from interviews, we will start from the interviews wide. And then we set it to pivot longer. So we just mentioned the first argument will be the data frame. The second one will be columns. And the third one will be names 2. And the third one will be values 2. I mean, the fourth one. Anyway. Okay, so for the columns, we are going to use the last 4 columns from Markdown to segment. So we will see. Some breaks. Burn break segment. Names 2, we will put them, we will create a new column, respondent war type.
You only have respond wall type. Did you mean that? I thought you meant.
Okay, respondent, thank
Yeah.
you.
Sure.
And this will be war type logical. And then we can take a look. We can send it to view. Burned. I think I misspelled burned. Okay, so we won't see those 4 columns, but we see the respondent war type and war type logical created here. And we see that this key ID, the first, I think in our data sets, we have 2 key ID, the first 2 records, I think both of them have the 1 as their key ID. So we can start from 3, let's say 3, we have 4 rows, and 4, we have 4 rows. So the reason why we have 4 rows, because they have those 4 different types of war types. And then only 1 is true. The other 3 are false. The same as this one. The war type is burn breaks, and this is true, but all the other 3 are false. So we don't really want those 4s to be there. Oh, and also we can take a look at how many rows we have. We can scroll down to the bottom. We see we have 524 rows, which is 4 times of 131, because we kind of expanded this row. Each observation, we expand them to 4 rows. But we don't really want those 4s listed here. So we can remove all those rows where war type logical is 4s. Okay. So we can use the function filter. And if we send them to view, and then first we can see we have only 131 records, and all the 4s are removed. And we don't really need this column anymore. We know they are all true. So we can remove the column. So we can use select, and then we use minus. Okay, if we send them to views, to view, and then we will see the last column, the war type logical, is removed. And this one should be the same as the data frame interviews. The only difference is respondent war type is moved to the end. It's not here. It's supposed to be here originally. Why do we want to do this kind of conversion from wider to a longer format? We can see an example. We still can go back to see our data. Let's say we have this column, items owned. That kind of puts all the items each family or each household owns. And they don't have the same, they don't have the same number of items. So some family may have 2 items, some family may have more. So to make the records, kind of when we do the observation, we just put them in one column. That will be easier for us to kind of collect information. But let's say if we want to see which item is the most owned, or we want to see the average items each family owns, or the average items each the average items by village, that will be difficult for us to calculate. So this way we can kind of change this format to make the calculation kind of easier. Okay, so I know this part is kind of confusing and difficult. Okay. So here we try to apply. We will apply pivot wider to clean the data. Okay. So still we will start with interviews. And first, we want to split this into, let's say we have two items in this row, in this observation, we want to split them into two rows, just like the long format or the tidy data format. The function we're going to use here is called separate rows. We are going to use some functions we haven't talked about in this example. So the row we are going to kind of separate is called items owned, and the separator we thought they are semicolon. Okay, so and then we can, okay, let me see, we name this as interviews items owned. Could not find function. Interviews. Oh, sorry. We name it. Okay, so then we can take a look. So it opens here. We can see items owned. Each cell has only one value. So the first two, originally it has two items in the first observation, but now it has only one, but the row is split into two rows. So this is kind of more like the tidy data. No, it's not really the tidy data, but that's the longer format. Let's put it that way. This is a longer format. Okay. And then actually we are going to do what we just did for the pivot wider, but let's say we know that some families doesn't really have anything. So their data is missing, so it's NA. But we will use NA. We will see NAs in the process of using the pivot wider. We don't want this NAs kind of confused with the NAs we were going to use in the pivot wider function. So we want to replace these NAs with something else. So in our case, we want to use the function replace NA, and then we will replace it item owned with no listed items. If a family, they don't have anything listed, we will use this. When we run it, and we can take a look how it looks like. Oh, this. And yeah, items owned, and even we scroll down, we see no listed items, but we won't see NA anymore.
And Jing,
And
we're
then,
10 minutes out.
okay. And then we're going to use the pivot wider. And first, we will add a new row that's called items. Items owned logical. It is true. And then we will add using the pivot wider. And we are going to use names from, that will be items owned, and then values from, yeah, that will be the items owned logical. And then we will replace the NA with false. Logical equal to false. And then we can take a look. Okay, so you can see all the items from bicycle to car. They are all kind of becomes the column name. If we want to kind of calculate how many items each family owns, we can, yeah, we can do it using another function called, we can add a new column. Let's say we can add a new column called mutate, and we column numbers items, and we're going to use a new function. It's called row sum, and this time we will select only the items from the columns from bicycle to card. This is the dot. It's kind of like this dot. It's the current data frame. That's not found. No. Rotate number items. I don't see any problems with this code.
Yeah, I don't either, Jing. I'm looking.
Hmm. Hmm. So items.
Oh, it worked for Brad. So you
Okay.
put something in there.
Okay, cool. So, let me see.
Does it need a space between the dot and the comma?
I don't think so. I don't
Okay.
need the space.
Okay.
Did I press anything wrong? here?
There's not a pipe on the line 138.
Oh, thank you.
Good job, Brad. Look, we're getting it. Oh, Kathy
And then,
got that too. Good job, Kathy.
and then we can see a new column added here. And basically it will calculate all the truths from bicycle to cars for each row. So here, this one, it has 2, 3, 4 truths, and all the fours till the end. So we got 4. Okay, so this is kind of the way we can we convert something long to wider to serve specific purpose. We want to find out the average how many items each family or each household owns, and we can just convert the original data into a wider format. Okay. So in our data sets, and except for the items owned, we have another column. It's called month lack of food, and it also kind of have the similar situation as the items owned. Some observations has more months, and others may have none or have less months. This one has only 2 months, and this one has 4 or 5 months here. So we can do the same thing for this column too, but the only difference is before for the items owned, we have missing data, we have NAs, but here as it's already kind of replaced with none, we don't have any missing data, we can skip this step. We can skip this replay. Oh yeah, we can skip replace NA. We can skip this step, and we can do the same thing for the column months lack of food. Those are the data. Let's say okay. So this will be the code. And I think we use the same name as long as I view. It should have not only the items they owned and also the months. And also it has none here. And we have 2 extra columns. One is number of items, another one is number of months, lack of food. The code are quite similar. I mean, to solve the, to kind of convert the, change this month's lack of food into the wider format. Then we can kind of export the data. So we're going to export data using the function write CSV, and then the first will be the table, the data, the data frame name. So we can just put it here. And then next will be the file where we want to put it. These are the data, but these are not the data the same as the data, the source. So we want to put it under data output. And then we are going to name it interviews plotting.csv. But we don't have the data output folder there. So before that, we want to create one. So that's dir create. And we will name it data output. So this is, oh, cannot find, oh, create. I missed an E. And then we write this file into the folder. So we can see we have this folder created and we have this file here. That's kind of all for today. I'm sorry we are run out of time. It's already 4:04. Do you have any questions?
Yes, Brad.
Yes. Yeah, we saw how we could, at the end, view without the logic, without a single logical column by using select. Is it possible to use select to remove from the viewing a series of columns? I tried minus bicycle through car, and that didn't work. Is there something that, is there language to use to do that?
I don't think so you want to move the columns.
So yeah, for example, removing a bicycle through car so that all we see in the resultant data frame is the new column that we created. If we don't see the splits, these separate, we don't see the long form, just what we were trying to create using the long form.
Oh, do you mean the this wider and it's already kind of let's say here, this wider function, it will kind of create the columns for you.
Right. So having created those columns, can we then, after the mutate, after line 157, before we view it, can we tell it we don't want to see bicycle through car as columns? We're on, so that we want when we view the data frame, don't show us bicycle through car. So after 157 or after the mutate.
So after this line,
So
next line changing, he wants to put it after the mutate.
after mutate.
Yeah. So
before we view it, once we've done everything.
Ah, got you.
There you go.
Okay, so it needs to be in parentheses. Okay. No, that still didn't like it.
And then we can view that.
Let's see if that works.
And then we don't see those bicycles through cars. So we already
Oh, okay. It did like it.
removed them.
Okay, great.
Are you good, Brad?
I think so.
Okay,
Mhm.
good question.
Yeah, it was just the parentheses. I had the minus sign, but I didn't know to put
Ah.
the range inside the parentheses.
Yes, yeah. You want to remove the whole range, so you must put them in the parentheses. Mhm.
Thank you.
Sure.
Okay.
Any other questions? I don't see any.
Okay, cool. Thank you for coming and stay safe and warm. And yeah, see you next week.